Welcome to chemistry classes. In this video we are going to discuss about states of matter. States of matter. Okay. So see here, states of matter. Observe these pictures carefully. Okay, here there are different type of objects. You can classify this object. Okay, there is water, ice, water vapor, oxygen, nitrogen, okay, oil, kerosene, wood. So you can classify this substance mainly solid state, liquid state and gaseous state. Solid state, here ice, wood, metals, these are example for solid state. Gases, carbon dioxide, oxygen, okay, these are example for gaseous state. Water, oil, kerosene, these are example for liquid state. So matter we can classify mainly three types: solid state, liquid state and gaseous state. Okay, first we have to discuss here. We have to discuss here solid state. Characteristics of matter. Characteristics of matter. First one, solid state. Solid state. Okay. So see here, compared to gaseous state, compared to oxygen, nitrogen, carbon dioxide, or compared to oil, kerosene, water, what you observe in solid like wood, wall, boat, these are not compressible. You can move your hand very freely in your air. Means air which contain oxygen and nitrogen, carbon dioxide, these are gaseous state, and these gases are highly compressible. You can compress it easily. That's why you can move your hand very easily in air. But we cannot move our hand through wall or wood or something, because here solids are not compressible. Solids are very hard, strong. Okay. So here you can see in this picture solid state, liquid state and gaseous state. Every states of matter made up of extremely smallest particles. Okay, these particles will attract each other. All matter made up of extremely smallest particles. These particles will attract each other. The force of attraction between solids are very strong force of attraction between solid particles. Okay, that's why solids are very hard. Particles are tightly packed. That's why solids are very hard, strong. Solids cannot compress very easily. Okay, solids are not compressible. But look here, sponge and rubber, they are solid. Here sponge you can compress, but it is solid. But why you can compress sponge? Between sponge there is free air space. That's why you can compress it. Okay. Also here rubber band, after putting some force you can enlarge it. When you release the force, it will come back to its original position. So here rubber band, also here sponge, they are solid state. Okay. So here we can say generally, solids are very hard. Okay, solid, they have definite shape, mass, volume. Okay, also solids are not compressible. Force of attraction between particles of solids are very high. Okay. And another thing you have to remember here, when you put water in the floor, you can see here water will move from one place to another place. Okay, you can see here gas, it will move very freely in air. It means water and air, or you can say liquids and gases they are fluid, they can flow. But when you put one piece of wood on the table, it cannot flow. It will stay on the same place. It means solids are not fluid, but liquid state and gaseous state, they are highly fluid. Okay, and solids are not fluid. So these are the different characteristics of solid states. Characteristics of solid state. Solids are hard. They have definite shape, mass, volume. Solids are not compressible. The force of attraction between particles of solids are higher. Okay, and here's another thing you have to remember here. Solids are not fluid. Clear? Next one we have to discuss here. Liquid state. States of matter, solid state we discuss. Next one, liquid state. Okay. So here I show you before the diagram here, liquid state. So you can see here in liquid state particles are loosely packed. In solid state particles are tightly packed, but in liquid state particles are loosely packed. Okay, so you can say here intermolecular force of attraction. Force of attraction between liquid state compared to solid state, force of attraction is weak. Okay, force of attraction between particles of liquid state, it is weak force. Okay, compared to solid state, it is weak force. That's why particles are loosely packed. Particles can move. Okay, particles are loosely packed. Also another thing you have to understand here, see this diagram. In liquid state, the shape of water, it depends on the container which it is taken. Okay, the shape of liquid state, shape of water or shape of liquids depends on its container. There is no definite shape for liquid state. It depends on its container. Okay, water, beaker or test tube, whatever it shape depends on its container. Okay, so you can say here example for liquid: water, oil, honey, kerosene, crude oil. These are example for liquid state. Okay, and liquids they have no definite shape. Their shape depends on their container. Okay, also when you put water on the floor, it will move. It will flow from one place to another place according to the slope of the surface. Okay, it's mean water can flow, or liquids it will flow. I told you before, solids not fluid, it cannot flow, but liquid it can flow. Okay, and another one here, here already we discussed force of attraction between particles of liquid, it is weak force. Okay, so these are the different characteristics of liquid state. Okay, here liquid state, they have no definite shape. Their shape depends on their container. Okay, and here liquids, it can flow. Force of attraction between particles of liquids are weak force of attraction. Clear? See here, this activity, when you add sugar in water, take one beaker with water and put some sugar and stir well. We can see sugar will dissolve. We cannot see sugar anymore. Means it dissolved. Okay, so where is this sugar? It's mean the water, I told you before, water it is liquid state and particles are loosely packed and there is free space between the particles of water. When you add sugar in water, this sugar will go to the free space of water, free space between the particles of water. That's why sugar disappear. Okay, similar thing also happen here when you add potassium permanganate in water. Water will turn to purple color. Okay, we cannot see potassium permanganate crystals. Only water turns to purple color. Okay, it's mean potassium permanganate crystal will go to the free space between the particles of water. That's why potassium permanganate crystals disappear. You understand? One we have to discuss here, gaseous state. Already we discussed here solid state, liquid state. Next one, gaseous state. So here first one you have to understand here, intermolecular force of attraction between gaseous particles are very less. That's why gaseous particles can move freely and randomly. Gaseous particles move very freely and randomly because the force of attraction between gaseous particles are very less. Also, gases, they have no definite shape and no definite volume. Okay, volume, there is no definite volume for gases. Okay, when you take gas or oxygen gas or nitrogen gas, any gas in a container, in a cylinder, it will take whole volume of the container. Because gaseous particles move freely and randomly, there is very less force of attraction between gas particles. That's why gases takes whole volume of the container. Okay, when you take water in a container, it will stay on a fixed surface, it will stay in a fixed level, because the force of attraction between liquid state compared to gaseous state, force of attraction between liquid state stronger. Okay, that's why it will stay together. But in gaseous state, force of attractions are very less. That's why it move freely and randomly. Okay. We can say this based on kinetic theory of gases. Kinetic theory. Kinetic theory of gas mean, here one question, what is kinetic theory of gas? So you can say here, the force of attraction between gas particles are very less. That's why gas particles have higher energy, higher kinetic energy. Higher kinetic energy. That's why gas particles move freely and randomly. This is called kinetic theory of gases. Kinetic theory means gas particles have higher kinetic energy and they move freely and randomly. Clear? Okay, next one we have to discuss here. Next one we have to discuss here, gas particles are highly compressible. Previously we discussed solids are not compressible, liquids are compressible, but gases are highly compressible. You know, the gas which obtained from crude oil, it is called petroleum gas. Okay, this petroleum gas used for cooking. Okay, we can compress this gas, we can put high pressure. At very high pressure and very low temperature, we can compress gas. Okay, so this is LPG, liquefied petroleum gas. Okay, when you apply very high pressure at very low temperature, gas will change to liquid state. So petroleum gas will change to liquid state, that is LPG, liquefied petroleum gas. Okay, and also you know natural gas. So this gas obtained from crude oil, petroleum, that's why liquefied petroleum gas. Also we will obtain gas naturally from underground. Okay, that is natural gas. Okay, so we can put high pressure in natural gas and we will keep this, and also we used both LPG and CNG as used as fuels. So natural gas after high pressure and very low temperature we can compress it, and it is called CNG, compressed natural gas. And this is liquefied petroleum gas. So here gases are highly compressible. So look here, the order of compressibility. Gases are highly compressible than liquid state, then solid state. Here solids are not compressible. This is the order of compressibility. This already we discussed here. Intermolecular force of attraction between gas particles are very less. That's why they can move freely and randomly. Okay, that is kinetic theory of gases. Okay, and here another one I told you, gases, they have no definite shape and volume. The volume of the gas depends on the container. Okay, it will take whole volume of the container. Same reason here, intermolecular force of attraction. Intermolecular force of attraction between gas particles are very less, so they can move very freely and randomly, and it will take whole volume of the container. Clear? Okay, and another thing we have to discuss here, when you take 2 cup of coffee, one with a hot cup of coffee and another one cold cup of coffee. So hot cup of coffee you can smell very easily. The smell of hot cup, hot coffee spread faster. Okay, why it is hot mean at higher temperature particles gain more energy. Kinetic energy of particles increases with temperature and it will move faster at a higher temperature. It will move faster at higher temperature. That's why here hot smell of hot coffee spread faster. You understand? A change of states. Okay, to understand change of states, look here. Consider one beaker. Consider one beaker which contain one piece of ice, and we kept a thermometer over here. Thermometer, and keep heating over here. We have to heat ice on a beaker, and we kept a thermometer. You know ice after heating ice will change to water again after heating it will change to water vapor. Ice change to water change to water vapor. So on heating, the temperature of thermometer will be increases. Temperature on thermometer will increase according to the time. Okay, so we can draw a graph according to this experiment. We can draw a graph here. Y-axis temperature and x-axis it is time. X-axis time and y-axis it is temperature. Clear? So here you have to understand here. Look here, different parts of this graph. Here first it is ice. Okay, then it is water, then it is water vapor. Okay, so when you move when the time is progress, the temperature on the thermometer will be increases. Temperature in thermometer will be increases with the time. Okay, so this is showing here in this graph. Okay, here temperature also increasing. Okay, so here A to B, this part A to B it is solid, A to B it is solid, C to D it is liquid state, E to F it is gaseous state. Solid state, liquid state and gaseous state. Initially it is ice means solid. Here ice means solid state. On heating it will change to liquid state. Liquid state means water. After heating ice it changes to water. Okay, again heating water change to water vapor. Okay, gaseous state means water vapor. So this I am showing here. A to B it is solid state, C to D it is liquid state, E to F it is gaseous state. Again you increase solid state, liquid state, gaseous state, it is finally water vapor. Again you increase temperature, so there is no any change of state, temperature increase like this. Okay, temperature will be increases, there is no more change of state. So here you have to understand different change of state. These are the different change of state. First one, melting. Melting means solid change to liquid state, ice change to water, solid change to solid state change to liquid state. This process is called melting. Okay, melting point means temperature at which solid change to liquid state. That temperature is called melting point. Melting point of ice we know 0 degrees Celsius. Okay, pure water or pure ice will melt at 0 degrees Celsius. If water is impure water, when you add some salt or sugar into water, then you change to ice. Such type of ice do not melt at 0 degrees Celsius. Okay, it is impure ice or impure water. It will melt less than 0 degrees Celsius, -3 or -5, -6. According to the amount of impurity, their melting point will be decreases. Okay, so you understand here, melting means solid state change to liquid state. This process is called melting. Melting point means temperature temperature at which solid state changes to liquid state, that temperature is called a melting point. Melting point of pure water, it is 0 degrees Celsius. If there is some impurity, melting point will be decreases, -3, -5, according to the amount of impurity. Okay, next one, boiling. Boiling means liquid state change to gaseous state, water change to water vapor. Okay, generally we can say liquid state change to gaseous state. This process is called boiling. Temperature at which liquid state change to gaseous state, that temperature is called boiling point. Boiling point of pure water is 100 degrees Celsius. Okay, pure water will boil at 100 degrees Celsius. 100 degrees Celsius. Clear? Okay, another thing you have to understand, if there is some impurity, for example, we discuss here salt water, sugar water, it will melt less than 0 degrees Celsius. Impure water will boil more than 100 degrees Celsius. For example, 105, 103, according to the amount of impurity. Okay, impure water boil more than 100 degrees Celsius. Impure water melt or impure ice melt less than 0 degrees Celsius. Clear? Next one, we have to understand here freezing point. Freezing point. Freezing means the change of state of liquid state to solid state. This process is called freezing. Similarly, temperature at which liquid state changes to solid state, that temperature is called freezing point. Freezing point. Also, there is another process, condensation. Condensation means solid directly changes to gaseous state. Okay, here look here. Here we have here one dish, china dish, okay, or we will say one apparatus in chemistry, we will say china dish. Okay, so here this is apparatus, china dish, it is small pot. Okay, we will take here ammonium chloride, it is white solid. Ammonium chloride, it is white solid. When you heat it, this ammonium chloride white solid directly changes to gas. Okay, and there is one invert funnel. There is a funnel we kept inverted. Okay, and the tail of this funnel put some cotton. So this vapor cannot escape outside. This vapor stay inside the funnel. Okay, so here ammonium chloride after heating it will change to ammonium chloride vapor. This vapor do not escape outside. It will stay inside only. Okay, so here this ammonium chloride vapor, after some time you can see on the tail of this funnel, you can see some white powder on the surface of funnel. It means ammonium chloride, it is solid state. After heating it directly changes to gaseous state. This gaseous ammonium chloride, after condensation, this ammonium chloride after cooling it changed back to ammonium chloride solid. Okay, here look here, solid ammonium chloride after heating gaseous ammonium chloride. Gaseous ammonium chloride on cooling again it changed back to solid. Solid changed to gas after heating. Gas changed to solid after cooling. This process is called sublimation, not condensation. Sublimation. Sublimation means the process by which solid directly changes to gaseous state. Similarly, gas directly changes to solid state. Both processes called sublimation. Okay, example for such type of substance, ammonium chloride, it will change to solid, directly change to gaseous state. Similarly, another one, camphor. Camphor is another substance, and another one, iodine, one chemical iodine. Okay, and another one camphor, and another one ammonium chloride. This type of substance, they are solid. After heating it will change to gaseous state directly. Okay, normally you know ice, after heating ice changes to water, water changes to water vapor. So here solid state, liquid state, gaseous state, three states. Okay, but here in this case solid directly changes to gas without liquid state. Such process is called sublimation. Clear? So here we discuss melting, boiling, freezing, sublimation. There is one more, it is condensation. Condensation mean gaseous state on cooling it will change to liquid state. Gaseous state change to liquid state. This process is called condensation. For example, you know water vapor. Water vapor after cooling it will change to water. You know from atmosphere we will get rain. Gaseous after condensation it will change back to water and it comes down as rain. This is condensation. Clear? So melting, boiling, freezing, sublimation, condensation, these are the different change of states. Okay. Here you have to understand from this graph I told you, here it is solid, here it is liquid state, here it is gaseous state. Again after heating the graph will move straight. There is no any change of state. So look here, uh, solid state mean you know from this figure you know solid state particles are tightly packed, liquid state particles are loosely packed, and gaseous state particles are further apart. Okay, so here it is solid state, here liquid state. Okay, here time is moving but temperature is not moving. Here temperature is constant. Also here temperature is constant. Between liquid state and gaseous state temperature is constant. Between solid state and liquid state temperature is constant. Why temperature is constant? Why temperature is not moving in this graph? Here we have to answer. Here it is solid state. In solid state particles are tightly packed. Particles are very closely packed. Okay. So here this we are heating, still we are heating. This heat energy used to separate intermolecular force of attraction. Heat energy used to separate intermolecular force of attraction. Here solid particles are tightly packed. Okay, to separate the particles heat energy used. That's why here heat energy not increasing. Okay, similarly here compared to liquid state, compared to gaseous state, liquid state particles are closed. In gaseous state particles are further apart but liquid state particles are close. Okay, so here still we are heating. Here temperature not increasing on the thermometer. This heat energy used to separate intermolecular force of attraction between liquid state. Okay, that's why temperature not increasing here. Also temperature not increasing here. This temperature used to separate intermolecular force of attraction between particles. Clear? Also look here, here it is solid state, here it is liquid state. So we can say this part BC is melting. Solid change to liquid state, it is melting. Similarly here it is liquid state, it is gaseous state. So here DE is boiling. Clear? So this is melting and this is boiling. Clear? Look here, first one, effect of change of pressure. See this diagram. When you change the pressure and temperature, what happened to gas? We know gas intermolecular force of attraction between gas particles are very less. That's why gas particles can move freely and randomly. Gas particles are moving freely and randomly. That's why during this motion, gas particles collide each other. Also, this gas particles collide with the wall of the container. When you take gas in a particular container, imagine it is a closed container. These are the gas completely filled in the container. these gas particles are moving freely and randomly. During their motion, these gas particles collide each other. These gas particles collide each other. Also, these gas particles will hit with the container. Gas particles will hit with wall of the container. Okay, this gas particle will collide with the wall of the container. That's why gas particles make pressure. You have one question here. Why gas particles make pressure? Gas particles, the intermolecular force of attraction between gas particles are very less. That's why gas particles moving freely and randomly. During their motion, gas particles collide each other. Also, it will collide with the wall of the container. Okay, because of it, it produces pressure. You understand? Also, look here, I told you before, you observe this figure. Okay, when you check the figure, you can see here, when you change the pressure, you can change the state of gaseous state can be changed to liquid state at very high pressure and very low temperature. By applying high pressure, gas particles can bring very close each other, then gaseous state will change to liquid state. Okay, condition for this, how can you convert gaseous state to liquid state? At very high pressure and very low temperature. Okay, also gaseous air we can change to liquid air by applying very high pressure and very low temperature. Same process also we can do here. Carbon dioxide, it is gaseous state. At high pressure and very low temperature, carbon dioxide we can change to liquid state. At very high pressure and very low temperature, we can change carbon dioxide gas to liquid state. Okay, here carbon dioxide in liquid state, it is called dry ice. Carbon dioxide in liquid state, it is called dry ice. Clear? Okay. After that, you have to understand here. Here one question. What is the physical state of water at 100 degrees Celsius? Before in this graph, I show you here melting, boiling. Okay, here it is solid state. Here it is liquid state. Here it is gaseous state. Here solid change to liquid state at 0 degrees Celsius. Okay, so this temperature will be 0 degrees Celsius. Similarly here, this temperature, here liquid state change to gaseous state. For in case of water, here this temperature, liquid state change to gaseous state, that temperature will be 100 degrees Celsius. Okay, at 100 degrees Celsius, water start to boil, water start to change water vapor. Water do not turns to water vapor completely, only water start to change water vapor. Similarly here at 0 degrees Celsius, solid ice do not change to water completely. Ice start to melt. Okay, also here same thing I told you here at 100 degrees Celsius water start to change water vapor. So here one question, what is the physical state of water at 100 degrees Celsius? So water, it will be at 100 degrees Celsius, it will be liquid state, also gaseous state. Water start to boil. So there is liquid water, also there is gaseous water. Similarly, what is the state of water at 0 degrees Celsius? 0 degrees Celsius, ice not completely turns to water, ice start to melt. So there is solid state, also there is liquid state. Clear? So here, what is the physical state of water at 250 degrees Celsius? More than 100 degrees Celsius, water completely turns to water vapor. Okay, not 100, more than 100. So when you take 250 degrees Celsius, water completely turns to water vapor. So at 250 degrees Celsius, water will be water vapor. at minus 5 degrees Celsius, or you can say minus 10 degrees Celsius, what is the state of water? It will be ice. At 30 degrees Celsius, which state water, which state? It is liquid state. It is room temperature 30 or 50 or 60. This temperature water will be in liquid state. Clear? Another thing we have to understand here, relation between Kelvin and degree Celsius. Kelvin and degree Celsius. Here you have to understand 0 degree. You have to remember this. 0 degree Celsius equal to 273 Kelvin. 0 degree Celsius is 0 degree Celsius 273 Kelvin. So look here. So 0 degree Celsius 273 Kelvin. Then 25 degrees Celsius mean how many Kelvin? You have question. Convert 25 degrees Celsius to Kelvin. So how can you convert this? 25 degrees Celsius will be equal to 273. Here we know 0 equal to 0 degrees Celsius 273. So 25 degrees Celsius will be 273 plus 25. So it will be 298 Kelvin. Similarly, you have another question. 10 degrees Celsius equal to how many Kelvin? So you have to do here 273 plus 10. Always you have to add 273 to convert to Kelvin. Clear? Similarly, you have another question. 573 Kelvin. How many degrees Celsius? So you have to do opposite. 573 you have to convert into degrees Celsius. So you have to do 573 minus 273. So it will be 300 degrees Celsius. Okay. Similarly, you have 600 Kelvin. 600 Kelvin. How many degrees Celsius? So you have to do here 600 minus 273. So this will be answer. Clear? So you have to do accordingly. You can convert degrees Celsius and Kelvin. Boiling and evaporation. Boiling and evaporation. Boiling and evaporation you can understand very easily. Take some pot with water. Take a pot with water and you have to heat it. After some time you can see water start to boil. Water start to change water vapor. Okay, so that is boiling. Boiling happen in bulk quantity. Bulk quantity of water change to water vapor. Okay, bulk quantity of liquid change to vapor in boiling. Also, we have to heat. We have to give some external energy for boiling. To change water to water vapor, to change liquid to gaseous state, we have to give some external energy. Okay, it happen with external energy and much quantity of liquid change to gaseous state, and it is visible. We can observe this. Okay, but you take some water, take a water bottle and put some water on the floor. Okay, you observe this. Put some water on the floor. Okay, at normal temperature you can see the water, but long time after you cannot see water. Okay, but you cannot see water change to water vapor. Okay, but there is no more water on the floor. This is example for evaporation. Evaporation mean very less quantity, minute quantity of liquid change to gaseous state. Minute quantity of liquids change to gaseous state. Okay, and it will happen at room temperature without any external heat. At room temperature it will happen at room temperature. Also, it is very minute quantity and not visible. Okay, these are the difference between boiling and evaporation. Boiling, it is bulk process, much amount of water change to water vapor. Evaporation, it is surface phenomena. Surface phenomena mean on the surface of water only. For example, you have pond water, pond, river, lake. At hot days, water changes to water vapor from river, pond, lake. It is not visible. But on the surface of pond, river, lake, water changes to water vapor. It is very minute quantity at a normal temperature, or with help of sunlight it will change to water vapor. Okay, so you can say it is surface phenomena. It happening on the surface of liquid. It is surface phenomena. Okay, also it is not visible. It no need any external temperature. Without any external temperature it will happen. For example, it happen at room temperature. Okay, so these are the major difference between boiling and evaporation. Clear? Okay, next one we have to understand here, what are the factors affecting evaporation. Okay, evaporation, rate of evaporation always same or different. Okay, so see here, these are the some factors which depends on the evaporation. First one, surface area. Surface area, you have one hot cup of coffee, okay, and you take hot cup of coffee and you take some hot coffee in a saucer. Which one evaporate, which one make cool easily? Here, hot coffee in saucer, it cool in the saucer, it will cool easily, not in the cup. Okay, in the saucer there is more surface area. You take some liquid, hot liquid in a plate or large surface, so more surface area there, so more air contact, more hot liquid contact with the air, and it will cool very easily. So surface area increases, evaporation increases. You understand? So this is the one factor. When you increase surface area, evaporation increases. Second one, wind. Second one, wind. Okay, if there is windy days, more water particles can escape from the surface of water to atmosphere very easily. Rate of evaporation increases with wind. Next one, humidity. If there is already water particles in the air, so that's mean humidity. If there is humidity in air, so rate of evaporation will be less. Okay, rate of evaporation will be less in humidity. So you can say humidity decreases rate of evaporation. Next one, atmospheric hotness. Hot days, sunny days. Okay, summer days, all pond, river become dry, means water will be evaporate faster in hot days. Okay, because water particles gain more energy, more kinetic energy, and particles can move faster. Okay, so these are the factors affecting evaporation. Surface areas, if surface area increases, rate of evaporation increases. Okay, next one, wind, humidity, and atmospheric hotness. These are the factors affecting evaporation. Okay, after that, next one we have to understand here, evaporation cause cooling. Okay, when you take some nail polish remover or acetone, or simply you can say you put some perfume spray, okay, perfume spray on your hand, okay, so you will feel cold. Okay, because it contain alcohol, acetone, or nail polish remover. Take in your palm, you will feel cold because it evaporate very easily. When it evaporating, during evaporation, it absorb energy. It absorb energy from surroundings. Okay, nail polish remover or acetone, it absorb energy from our palm. Okay, absorbing energy from our palm, that's why we feel cold. Okay, so see here, same thing happening when you take one piece of ice in your hand. Ice, it will melt at room temperature. So when you put ice on your palm, ice will absorb energy from your palm. That's why you will feel cold. Clear? So here this is the reason evaporation cause cooling. What is the reason? Particles of liquids absorb energy from surrounding. That's why evaporation cause cooling. Okay. We are discussing in this video. Next part we will discuss in next video. Okay. Thank you for watching this channel.